Okay, guys, so this is going to be a video on a couple of the problems from the integral as net change homework assignment. It was requested that I go over a couple of the problems, and I'm going to make a video on each one of those problems. So again, if you have questions, you can take a look at these videos, and it'll hopefully explain the different components of it. Just as an FYI, I am working from home today, so you may hear my son in the background, and that's just what that noise is in the background. It's my son playing. So anyway, so on problem number 6, we were given this problem, right? The temperature outside a house during a 24-hour period is given by this function, f of t equals 80 minus 10 cosine pi of t, or pi times t over 12. On that period, 0 is less than or equal to t, which is less than or equal to 24, where f of t is measured in degrees Fahrenheit and t is measured in hours. And so then on the first part of this, it says find the average temperature to the nearest degree Fahrenheit between t equals 6 and t equals 14. And so where I like to start with this is I like to draw out the function just so I have kind of an idea or a vague sense of what we're working with here, right? And so let's start with that. Let's draw out, that is a terrible looking drawing. Let's just draw out what this function looks like. And so I'm going to draw this out, and I'm going to put over here, this is going to be my degrees Fahrenheit, and this is going to be t. So my x-axis is going to be time, my y-axis is going to be degrees Fahrenheit. And I know I'm going to go from 0 to 24 degrees, or 24 hours, okay? And so just looking at this function, there's a couple of plot points that we can put in right out of the gate. We know we can start with cosine at 0. So time t equals 0. At time t equals 0, we got pi times 0. That's 0 over 12, which is 0. What is the cosine of 0? Okay, so this is one of those numbers, one of those values that you should know. Cosine of 0 is 1. Okay, so 1 times 10 is 10. 80 minus 10 is going to be 70. And so I'm going to put a mark over here. This is going to be 70. And then we'll do, let's say, we'll do this one's going to be 80, and this one's going to be 90. Okay, so I know that at time t equals 0, we're at 70 degrees. So that's going to be a significant point for us. Let's do the other extreme on this function, or this interval that we have. So at time t equals 24. So again, we've got t equals 24, 24 over 12, that's 2 pi. What's the cosine of 2 pi? Well, that is also the same value as cosine of 0, which equals 1. So cosine of 2 pi is 1, right? 1 times 10 is 10. 80 minus 10, that's going to be 70. And so we know that our starting and our ending values at time t equals 0 and time t equals 24, the degree temperature is going to be the same inside this house. It's going to be 70 degrees, both at the start and at the end of this function. Now, there's another significant value within this function that we can mark down between the time t equals 0 and time t equals time t equals 0 and time t equals 24. And that's going to be where we have cosine of pi. Right? So if we were able to find a value for t where we just get pi, right? Cosine of pi is going to be -1. Right? So that's -1 times 10. 10 times -1 is going to be -10. 80 minus a -10, that's going to become 80 plus 10, which is going to put this value at 90. Right? So the question is, what value can I put in for t between 0 and 24 that's going to eliminate that denominator? Well, if we put 12 in, t equals 12, right? 12 over 12, that eliminates itself, and then we just have cosine of pi. And so we know that that value is going to be 90 degrees. And so we can mark that one too. So right smack dab in the middle of our function at time t equals 12, we have 90 degrees. And so we can kind of sketch this out a little bit, right? We got kind of a vague idea of what this is going to look like as time goes on. Okay. And again, we're working with my drawing skills, so work with me here a little bit. We got kind of a little bit of this curve going on, right? Okay, so now we have kind of a visual of the function. And so let's go with now starting to evaluate this first problem. So find the average temperature to the nearest degree Fahrenheit between times t equals 6 and times t equals 14. Okay, so average temperature, well, that's just going to be the temperature, right? The temperature of this function between that time, t equals 6 and t equals 14. It's just going to be the integration of that time of f of t, right, with respect to t, divided by the overall time, right, the interval of time. Well, we can simplify this just a little bit. 14 minus 6, that's going to be 8. So we've got this integral divided by 8, or we can write it this way. 1 over 8, the integral from 6 to 14 of f of t dt. Okay? Now, what we want to do here at this point is we want to evaluate this integral. Okay, so they asked us to evaluate this to the nearest degree. So what I'm going to do is I'm going to pull up my calculator, and I'm going to put this in as a y1 value. Okay, and so for y1, I'm going to put in f of t. I've got 80 minus, I've got 10 cosine, and I'm just going to put in an extra parentheses in there. You're not going to screw up the calculator by having those extra parentheses. Pi x divided by 12. And I just want to make sure that it does that pi times x divided by 12 first, and then the cosine times 10, and all of that. Okay. And now at this point, you can do one of two things. You can do the integration and then divide by 8, or you can do this. You can do 1/8 times, and then math 9 pulls up my integration, and then I go 6 to 14, alpha trace y1 x. And there we go. So I get 87.161. So this is going to be equal to 87.161 degrees Fahrenheit. Or, and again, we go back to what the problem said, to the nearest degree, right? That's what they wanted it. So in this case, 87 degrees Fahrenheit. Okay? And so that's going to be the answer for this first one, 87 degrees Fahrenheit. Now, part 2 of this problem. Okay, so part 2 said an air conditioner cooled the house whenever the outside temperature was at or above 78 degrees Fahrenheit. For what values of T was the air conditioner cooling the house? Okay, so let's go back to this drawing. And if I can, I'm going to try to grab it. Okay, let's see if I can copy it. And then I'm going to paste it. Oh. Okay, so part B has us going, the air conditioner cooled the house whenever the outside temperature was at or above 78 degrees Fahrenheit. For what temperatures or what values of T was the air conditioner cooling the house? Okay, so what I want to do first is I want to see if I can grab this little graph that we did. Okay, I'm going to see if I can copy it and paste it. Oh, there it is. Okay. Let's see if I can grab it and paste it. Oh, here we go. So I want to take that, and I'm going to actually just grab it again and just move it a little bit down. Okay. And so what I want to do is I'm going to stick it right here just so we can look at it. Okay, so we've got our graph. Again, it's not the greatest graph in the world, but we got our graph. And so what it's asking us for is that there's an air conditioner unit that kicks in whenever we hit 78 degrees. Okay, so whenever there's 78 degrees, all of a sudden this thing kicks in. And so I'm going to draw a line right around 78 degrees. Okay, so this is my 78 degrees line. Okay, this is 78 degrees. Again, I'm kind of ballparking it with my graph here. It wants to know what values of T was the air conditioner cooling the house. So there's a value that occurs right about here, right? And then there's another value that occurs right about here. And so we want to figure out what these values are. I'm going to label this one A, and I'm going to label this one B. Okay, so I want to know what are those values of A and B. Well, in this particular case, we can go back to our calculator and let the calculator do the heavy lifting for us. And so I'm going to go back to Y, and I'm going to go back to my graph, and I want to put in a different value. Okay, so I'm going to put in for Y2, I'm going to put in 78. Okay, so I'm going to create a graph, and I've got these two values. And for this, I want to create a window of values so that way I can see what I'm working with here. What I'm going to do here is my window is going to be from 0 to 25 because we're working from 0 to 24 hours, right? So I want from 0 to 25. And then for my Y values, for my sake, I'm just going to do 65 to 95. Okay, that should get me a big picture of what we're graphing. Okay, so if we go ahead and graph it, we get this nice kind of bell curve. And then again, we've got that nice cut right there. So that bell curve right there is that temperature rising and falling within the temperature or within the house. And then that cut right there is going to be the temperature of 78 degrees. So that's kind of our line of demarcation, if you will. Now I want to know that point right here and that point right here. I want to know what my A and B values are. This is where that time kicks in and it starts cooling the house. And so we can do this pretty easily, right? We can have this calculate this out. So if we go to calculate and then 5, right, that's trace. And then I just kind of go over a little bit, first curve, second curve, and then I just scroll over to the left so that it kind of guesses for me. Intersection point, 5.230869.4. And there we go. There's my first point, point A. And so if I go back over to my graph here, I say f of t equals 78. And so t equals, and what did we say? We said it was 5.230. 5.230 equals A. And what I want to do now is I want to take this, I'm going to quit, and I'm going to do x equals, and then what I'm going to do is I'm going to go to store alpha A. And now that's stored it in A for me, okay? So I'm going to use this value a little bit later on. Now there are two values, right? We just got A, we want to get B. So let's go back to our graph. We're going to go to second calculate. We're going to go to intersect. And again, I like to scroll over just a little bit so that way it has my values. And then I want to scroll over to the right now so that I'm guessing close to what it's going to be. And now I've got my second intersection point. And it says 18.769. Okay, so now t equals 18.769, and that equals my B value. And I'm going to take this information and I want to just put this in my calculator real quick. So I'm going to go to second quit, x equals, and again, see now it stored that value in for my x. So now what I want to do is take store alpha, and I'm going to put it in for B. Enter. And now it's stored that value in for B. Okay? Now, let's go back to our problem. We've stored in, we said f of t equals 78. We figured out my values for t. So the last thing we want to do is let's answer the question. Remember, we always want to make sure that we answer the question. We did it clearly. So the air conditioning, conditioner, excuse me, was cooling the house for t that exists at 5.230 and at 18.769 hours. Okay, remember our units, okay? Got to remember our units. That's very, very important. So there's our answer right here. Okay, so time t equals in those two intervals. That was when it started cooling the house. Okay. Now, let's move on to part C of this. The cost of cooling the house accumulates at a rate of 5 cents per hour at each degree the outside temperature exceeds 78 degrees Fahrenheit. What was the total cost to the nearest cent to cool the house for this 24-hour period? Okay, so now we need to know what's going to be the total cost of cooling the house over this 24-hour period. Well, only we want to know every time it's over 78 degrees, there's a cost associated with that. Anytime it's under 78 degrees, we don't really care. Okay, so what I want to do first is I'm going to take this little bit of info. Okay, I'm going to take it and I'm going to copy it. Okay, so there we go. We've got, I'll move this so it'll be a little bit easier. And what I'm looking for specifically is this little bit right here. Okay, all I'm looking for is this area. I'm looking for that area between those points A and B because that's when the air conditioner kicks on, right? That's the only time that the air conditioner kicks on. So that's the only time that there's going to be a cost associated with anything going on. So the cost is going to equal 0.05, right? That's the cost per hour, the cost over hours per Fahrenheit, degrees Fahrenheit, times the integration from A to B of f of t minus 78 degrees, basically, with respect to t. Okay? So again, this is the cost of the integration of f of t, the total integration, minus s of 78 degrees. So we are basically, what we're doing is we're finding the area of this entire integration, and then we're subtracting out the area of the integration below this curve of 78. And we're specifically doing it actually just in this little section right here. Okay, so we're just covering this section from A to B. We're finding this entire integration and we're cutting out this bottom part. So we're only finding this little bit because that's the only part that's going to cost us anything. Okay, and so again, we can go back to the calculator and let the calculator do the heavy lifting for us. Okay, and so what we do is we can do 0.05 times math 9. It's going to be alpha A, right? That's our first point. We're going from alpha A, then we're going from alpha B. That's our second point. We stored those values into the calculator for us. We're going to do alpha y1 minus, we could do 78 dx. Okay, and if we do all of that, it's going to come out with this exact number. And so then our cost becomes $5 and 0.096. So this is equal to $5.09, or you could say $5 and round up and 10 cents. Okay, and so there's our final answer. And again, all of this was taking the calculator and knowing what values to input in. Again, if you have questions on this, please let me know. But essentially, all of these different sections just built upon each other. We were looking at the average temperature, and then we were looking at just a section of it where these intersection points were, and then we were trying to find just the specific area.